Hey everyone, in this video we're going to talk about volume and surface area, and we're going to have a look at all the formulas given to us in the formula booklet and see how we can use this in various examples. The first shape that we are going to look at are prisms. So prisms are basically shapes, three-dimensional shapes of course, where you have two bases. So the two ends are identical and they're parallel to each other, and all the other faces are rectangles. So you can see a variety of different prisms on the right top and on the left hand side. So basically a prism is when you have those properties, and you can have a variety of different bases for your pyramids. So you can have like triangular prisms, hexagonal prism, rectangular prism, or a cube. Whatever the face is, this is how you define the prism. So whatever this shape is of the base, that's how you're going to define the prism. What's important for the prism is that once you know what the face of the base is, this is what we're going to call the area of the base. You need to find that area, and that's multiplied by the height of your prism. So the height of the prism is always the distance between the two bases. So this is going to be the height of our prism. And that's true for any prism you see. We're going to have the height, and then we have the area of the base. So this area of the base does change depending on what base we're looking at. When we're considering surface area, well, for surface area, what I find really helpful is trying to have a visual of what the prism looks like when you open it up and unfold it. Remember, surface area, you're trying to paint all the faces. So it's going to be important to have a visual of the net. This example, find the volume of the triangular prism whose base is an isosceles triangle where the equal sides are 12, so we see the 12s here, and the angle between them is 130. The height of the prism is 15. So the height of the prism is the distance between the two triangle bases. So if we look at our prism here, the height would be 15. The triangle that we see is the base, and they have a replication of the base right here. In order to find the volume of this triangular prism, we need to remember the formula for a prism, and the area of the base, well, it's the area of this triangle. Now this requires us to think back of things we learned previously. The area of a triangle, we can use the equation 1/2 AB sine C when you have the two sides and the angle between them. So we have 1/2 times 12 times 12 times sine of 130. And we're going to use that to find the volume. So the volume is going to be the area of our base times the height. The height is the distance between the two bases. And when you put all of that into your calculator, you're going to get that the volume is 827 centimeters cubed. The second shape that we see in the AI course are pyramids, and we're only going to be looking at what we consider to be a right pyramid. And a right pyramid is the type of pyramid where you have the apex, the very top of the pyramid, be exactly in the middle of whatever your shape is at the bottom. And the shape will always be a regular shape. And it's going to be the exact center, and it's right because it forms a right angle triangle at the bottom. So in the AI course, we're only dealing with right pyramids. Interesting things about pyramids, we have to consider the lateral face. So if we look at a pyramid, each faces of the pyramids create triangles. So you have one base that can be whatever shape it wants. It can be a square, it can be a hexagon, it could be a pyramid, any shape you want at the base, but then all the other faces are identical triangles. And these identical triangles, we can look at the these lateral faces, and one thing is going to be important that's going to pop up, and it's what we call slant height. So this distance here is going to be called our slant height, and we're going to need this when we do the calculations for surface area. When we talk about a pyramid, again, it's going to be important to see the pyramid as a net when we are doing surface area questions. There's not a specific formula for surface area of a pyramid, so it's going to be important that we realize that we have to do the area of the base and then add all the identical triangles in order to find this total surface area. When we're looking for the surface area, the volume of a pyramid, the volume of the pyramid formula is given to you in the formula booklet. And we notice that the volume is a third of what we just saw for a prism. So this is the volume formula for a prism. So this is for a prism. And the volume is just a third of that. And the reason behind that is when you have any given pyramid, so let's say we have a square-based pyramid. This is a beautiful interpretation. Well, this pyramid, if I fill it up with water and I try and dump it into a prism that has the exact same base and the exact same height, ooh, there we go. You're going to see that I can actually do this 3 times. And I encourage you to look at a video and see this happen or try it yourself. The important thing is that the bases are exactly the same. So this base is identical to this base and that they have the same height. And you're going to notice that this pyramid fits inside the prism exactly 3 times. And that's the reasoning behind our formula. Now let's look at our example. We have a right pyramid with a regular hexagonal base. So hexagonal base, we have 6 sides to this hexagonal base. Has a vertex height of 5 centimeters. So the height of this pyramid is 5 centimeters. So the height is going to be 5 centimeters. Each side of the hexagon is 4 centimeters. So each side of the hexagon is going to be 4 centimeters. Find the volume of the pyramid. Give your answer as a decimal, correct to 3 decimal places. Some of you might remember from previous geometry classes that there is a formula to find the area of regular shapes, regular polygons. However, this formula is not in the AI course and it's not in the formula booklet, so you will never have to use it. There's always another way that we can find the area of these bases. If we look at this hexagon, we have a situation where it's a regular hexagon, meaning that all the sides are equal to each other. Therefore, all these sub-triangles that you see inside of the hexagon are also equal to each other. And not only the equal to each other, they're equilateral triangles. So all of these also have a dimension 4 by 4 by 4. So if we're trying to find the area of one of these triangles, then we can simply multiply that by 6 and we're going to be able to find the area of the whole base. So we're going to start by doing that. Let's look at one of these triangles more in detail. So this is the triangle and it's 4 by 4 by 4. And we're trying to find the area of this triangle. Now we have 2 formulas that we know for the area of a triangle. 1/2 a times b times sine of c, or we have 1/2 base times height. In this situation, we can use the first formula because since we have an equilateral triangle, all the angles are equal to 60 degrees. So I can say that the area of one of these triangles is 1/2 4 times 4 times sine of 60. And therefore, this is the area of one of these triangles. So the area of the whole hexagon is going to be 6 times this. So the area of the whole hexagon is going to be 6 times 1/2 times 4 times 4 times sine of 60. And now we're in a good position to find what is the volume of this whole right pyramid. So the volume of this pyramid is going to be 1/3 times the area of the base times the height of the pyramid. So we're going to have 1/3 times the area of the base is 6 times 1/2 times 4 times 4 times sine of 60. At any point, feel free to simplify this if you want to. I'm just keeping everything here so that we don't make mistakes when we put it in the calculator. And then the height of our pyramid is 5. And when you put all of this information in your calculator, you're going to get that the volume is 69.3 centimeters cubed. The next shape that we have in AI course is a cylinder. A cylinder could technically be seen as a type of prism because we have 2 bases that are identical. However, what's connecting them is not a rectangle. It's actually a curved surface going around it. But this explains the equation for the volume of a cylinder. If we look at the volume of a cylinder, pi r squared, we recognize that as the area of a circle. And then we multiply that by the height, which is the distance between the 2 circles. So this equation is the same equation that we have for any prism, area of the base times the height. So that's where this equation comes from. When we look at the equation for the surface area, we can also notice some equations that we've seen previously. 2 pi r, well, this is the circumference of any circle. So the circumference is going to be the perimeter of this circle. And then we are multiplying that by the height. So it's going to be the whole circumference of the circle times the height. So this is going to be the equation only for the curved area. So this is only for the curved surface. And then if you're looking for the total surface area, so the area total, you're going to have the curved surface. And then we cannot forget that we have the 2 bases. So we're going to have 2 times pi r squared. And that would be the area total. Notice that in your formula booklet, they only give you the curved surface, and you have to think about what is the area total. The next shape we have is a cone, and similarly as we did for the pyramid, we're only going to be dealing with what's called a right cone, meaning that the apex is directly in the center of the circle this time. Slant height is still here, so the slant height is similar to what we had for the pyramid. If we look at the volume equation, you'll notice that the volume equation again is using this 1/3 compared to what we have for the cylinder. So this is the equation for a cylinder, and we have the 1/3 multiplied. So same situation as I was explaining before between the relationship between the pyramid and the prism. The same relationship holds true with the cone and the cylinder. And then for the surface area, we have to consider 2 parts. First, the base is something to consider for the area. And then the formula booklet gives us what is called the curved surface. So when we're looking at the curved surface, we're meaning the part that creates the cone shape. And in order to find that, what we're doing is we are using the formula pi r times the slant height. So pi r times the slant height is going to be the formula to talk about the surface area of the curved parts. Okay, so for this example, we're told a waffle ice cream cone has a diameter of 5 centimeters and a slant height of 12 centimeters. calculate the volume. Let's always start by doing a visual of what we are dealing with. Hopefully your drawing skills are better than mine. This is what I am able to do. And then what we do with this diagram is we put all the information given to us from the question. So first, the diameter is 5 centimeters. So diameter is the whole thing, is 5 centimeters. Often it's going to be useful to have the radius, so I'm just going to write down next to it. The radius is going to be 2.5 centimeters, half of the diameter. Next information is the slant height is 12. The slant height, this is the height that is not perpendicular to the base, but it's the one slanted, and this is 12. And we are asked to find what the volume is. Well, the volume formula for a cone, if we use our formula booklet, is 1/3 area of the base, which is our circle, times the height. So 1/3 pi r squared times the height. Okay, we do not have the height yet. The height is this distance here. So in order to be able to use the formula, we're going to be needing to find what the height is. So what I'm going to do is I'm going to redraw the triangle that I've just created using the slant height, the height, and the radius, which is 2.5. So I don't know if you can see this triangle here that has just been created. Well, this is a right angle triangle, and I have two sides, and I'm looking for the third side. So I can use Pythagoras' theorem here that states 12 squared, the hypotenuse, is equal to 2.5 squared plus the height squared. So using this, I get that our height is going to be equal, so I can put this into NSOLV, and I get the height is equal to 11.7 centimeters. And now we're ready to find what is the volume of our cone. So we can use the equation 1/3 pi r is 2.5 squared times 11.7. Putting all this in your calculator, you're going to get that the volume is 76.8 centimeters cubed. The last two shapes we are going to look at are a sphere and a hemisphere. So a sphere is a ball, basically, right? And the two formulas are given to you. So the volume formula is 4 divided by 3 pi r cubed. Make sure you look at your formulas correctly. I think this is the most common mistake. We forget that there's a exponent 3 instead of an exponent 2 here. And then the surface area, imagine you painting all around this ball, is 4 pi r squared. And that is the equation for a sphere. And let's look at the equations for hemisphere. Hemisphere is just half of the sphere, right? So when we take the equation for the volume, well, it's just natural that the volume is going to be exactly half of the volume of the sphere. So you'll see the equation is 2/3 pi r cubed. And then for the total surface area, we have to be careful about this one, because now what we've created is we have, yes, half of the outer layer is there, so half of this outer layer is there, but we now have a whole circle which is also there, so we have to include also the area of the circle. So the total surface area for a hemisphere, we have the circle plus half of the outside layer, so we get a 3 pi r squared. Now let's look at what formulas are provided to you in your formula booklets and which ones you should probably remember. So we have our volume formulas for pyramid. So let's highlight what we have for volume. Pyramid, cone, sphere. Those are the volume formulas that we have. You don't have the volume for hemisphere. So hemisphere is missing, which is just half of the sphere, right? And then for the prism, we're going to see it on the next page. So hemisphere is not here. Prism is on the next page. And then we have the area formulas for the cone. So look again for the cone. It's only the curved surface area for a cone. So very important that we remember this. And then we have the surface area for a sphere. Again, hemisphere is not here. This list of formulas is provided in the unit 3, so geometry. But there are other formulas at the very start of the book. At the very start of the formula booklet in prior learning, you're going to find a whole bunch of formulas that are useful, including the volume for a cuboid, the volume for a cylinder, and the volume for a prism. So all the shapes we've seen, the volume is here except this hemisphere. You also have the surface area for the curved surface of a cylinder. On the previous page you had for a cone. On this page you have for a cylinder. And then you also have some useful equations for the area of different two-dimensional shapes. So depending on what the base is, for example, of a prism, you might need to know what a trapezoid area is, and they give you some reminders here. Now the real interesting stuff is when you start combining all these shapes together. Rarely does the IB provide you one single shape. There's often going to be a combination of shapes together, and that's what we're going to have to find the volume or the surface area of. So let's get going with all these different types of questions. First example, a wooden spinning toilet is made up of a cone, a hemisphere, and in between you have a cylinder. The height of the cone is 4 centimeters, and the base of a base of a radius of 2. So let me draw that down. So we can imagine this cone has a circle as the base, and the radius is 2. What is the total volume of this toy correct to 3 significant figures? Okay, so we have 3 objects connected together to create a toy. We have a cone, a cylinder, and a hemisphere on the top. This little thing is just a decoration. Okay, so the area, so we're looking for the volume total, sorry. So the volume total is going to be the volume of the cone plus the volume of the cylinder plus the volume of the hemisphere. Let's look at all of these separately. So the volume of a cone, we go back into our formulas and we get 1/3 pi r squared times the height. So for the cone, we have 1/3 pi, the radius is 2, and the height we are told is 4, so times 4. So that was for our first shape. The cone is all set. Let's move on to the cylinder. So let's try and use a different color. So the cylinder, the area formula is the area of the base times the height. So my base is pi 2 squared, and the height is 5 centimeters. And then our final shape is the hemisphere. The equation for a hemisphere is 1/2 whatever the equation for the volume of a sphere is. Remember, hemisphere, the equation is not given to you, only for the sphere. So I'm going to use the equation for the sphere, pi r cubed. And again, we have all the information because this circle is the exact same as this circle. Therefore, they have the same radius. So we have 1/2 4/3 pi 2 cubed. And then we can put all of this into our calculator, and we are going to get 96.34 centimeters cubed. Example 2. A cylindrical can holds 3 yellow tennis balls. Each yellow tennis ball has a diameter of 6 centimeters, which is the same diameter as the cylinder. And the cylinder is filled to the top. Calculate the volume of the space in the cylinder not taken up by the yellow balls. Okay, so for this question, we have to imagine this typical tennis container for the tennis balls. And we are told that the diameter is 6. So from one end to the other end, we have a diameter of 6. And that can be the same thing from the bottom to the top. This can be seen as 6. So therefore, if we try and find the height of this cylinder, well, the height is these 6 balls together. So 6 times 3. And then the diameter is going to be 6. Therefore, the radius of our cylinder is going to be 3. And we're trying to find what is the volume of the space not used by the tennis ball. So the volume of the space is going to be the volume of the cylinder minus 3 times the volume of each ball. Okay, let's first talk about the volume of this cylinder. With a cylinder, pi r squared times the height, and we have the radius, which is 3, and we have the height, which is 18. So we're all set for the area, for the volume of the cylinder. Now let's talk about the volume of one of these balls. So one of these balls, we said that they have a diameter of 3, therefore the radius is equal, the other way around. They have a diameter of 6, and the radius is equal to 3. Each of these balls are a sphere, so we're going to use the sphere formula, which is 4 over 3 pi r cubed. So 4 over 3 pi 3 cubed. And then we can put all of this into our calculator, and we are going to get that the difference between these two volumes is 170 centimeters cubed. Okay, so now that we're comfortable with three-dimensional shapes, we've reviewed triangles as well. These are some typical questions that the IB like to throw our way, which is combining everything together. So angles, triangles, three-dimensional shapes. So many times they're going to ask you questions that are dealing with angles between lines. For example, find this little angle beta in the prism that you have here. My tips are always to never round your answer until the very end. So you'll notice that when I do my calculations, I write the full equation, and then the final step is I put everything in my calculator. I don't use my calculator throughout the questions. And then the second tip, and I cannot stress this enough, please sketch. Always do a little visual of what you have. For some questions, you'll have to sketch, and sketch again. You might have many drawings for one question. Let's try this example. So you have your shape. This is the rectangular prism. And there we go. They're asking you calculate the angle between the diagonal DB, and LB. So these two diagonals, calculate what the angle is between them. Okay, now here the diagram is given to us, and they highlighted what triangle we need to use. I always suggest that once you have a three-dimensional shape and you've identified a two-dimensional shape, please redraw this two-dimensional shape to understand it better. So I'm going to redraw this triangle that we see here. And this triangle has L, D, and this is B. And what do we know about this triangle? Well, we're trying to find this angle. We know this side is equal to 5. Now we don't know what DB is. So DB, we don't know what this side is yet. However, I can create a second right angle triangle, and this will allow me to find what DB is. So this right angle triangle, let me create it. and I already have it here. This is what we have for this triangle. I can use this in order to find what the missing side DB is, because I have a right angle triangle and I'm dealing with Pythagoras theorem here. So this is going to be this side here, let's call it y, because we already have an x. Y squared is going to be equal to 3 squared plus 8 squared. So we're going to get that this y is equal to, we can leave it as the square root of 73. That would be my suggestion. And then we can use this now into our first triangle that we drew. DB is this one, 73. So DB here is the same DB here. And now we have enough information to find the missing angle. I'm looking for an angle. I know what the opposite and the adjacent side is. So the tangent of my angle is 5 over the square root of 73. Remember, I keep square root of 73 because it's going to be a more precise answer. And when you put that into your calculator, you get that the angle is 30.3 degrees. And the last question for this video, the square base pyramid ABCDE is shown below or next to you. The height is 12. The length of each side is 8. Find the angle between EA and the base. So let's try and have a visual of what this is. EA is this here. And we're trying to find the angle between EA and the base. So for the base, I can draw a line connecting A and H. And I'm looking for this angle here. Now, it's pretty hard to see in 3 dimension, which is where my tip of redrawing in 2 dimension comes in really handy. What I'm going to do is I'm going to redraw this right angle triangle. So I have the height going from E to H, and this is connecting to A. This forms a right angle triangle. The height is 12. Okay, and we are trying to find this angle, which I'm going to call theta. There's a few steps that we need to take in order to get to finding first what AH is, and then once we know what AH is, then we can figure out what the angle theta is by using trig ratios. So first, let's look at what AH is in our diagram. I'm going to redraw the base so that we have a better visual 2 dimension to see what we have. So we have a square. We have A, B, C, and D, and in the middle we have H. Each of these sides is 8 centimeters. And this side AH is this one here. Perfect. This is AH, and we want to know how long this is. Well, there's a few ways that you can see that. The first way is you could see AH as half of the diameter of this circle. Not the diameter, the diagonal. So half of the diagonal is AH. So if I try and find the whole diagonal, well, this diagonal is going to be the square root of 8 squared plus 8 squared. We're using Pythagoras theorem. And then AH is half of that value. And then once we have AH, well, we can use it in our right angle triangle, and we can find what our missing angle is. So we have tan of theta is equal to 12 over 1/2 the square root of 8 squared plus 8 squared. And then when you put that into your calculator, you're going to get that the angle is 64.8 degrees rounded to 3 significant figures. Again, many different ways of getting to our AH. What you could have decided to do instead is create a smaller right angle triangle where both of these are 4, and then you would have got your AH using Pythagoras theorem as well. Hope this video was useful, and the trick to these geometry questions is practice, practice, practice. So make sure you have the formula booklet handy and try out all these different questions.